Hey guys, welcome. In this video, we're going to look at data types in Postgres. Let's begin. In every programming language that you're learning, it's very important that you know the different data types in that programming language, and Postgres is no different. Understanding the data types is crucial because it helps you when you're defining the table schemas and when you're working with the data. So as a data engineer, when you're creating the database, you know what kind of data type will fit the particular data you're handling. For example, if you're working with names, you have a student table and you want to store the names of students, you know that you're going to probably use a text field or a character data type to store that. And if you want to store the student age, you're going to use maybe an integer, something numeric data type. So that's what data types, understanding data types helps you with. And as a data analyst, because you'll be working with data, it will help you understand how you can analyze a particular data, what kind of operations you can do on the data. Another reason why it's important to understand data types is this point where you see that different types of data are stored differently and take up different amounts of storage space. So you want to know the right data type to use so you don't use one that takes too much space when it doesn't have to take a lot of space. We're going to see an example of that. Also, some operations only apply to certain data types. This is what I was talking about when I said you need to know the data type so you know the right kind of analysis to perform. Example here is addition of numbers, concatenation of strings. Let me tell you a little story. So there was a company I was helping evaluate their product. So I was doing quality assurance, and they have this product where their customers can sell their things and then they pay the customers for selling their things. There was a mistake in this app. There's a mistake. It was performing concatenation instead of addition. So let's say the customer is selling an item of 100 naira and the customer is also selling another item which is 200. If you add these two items together, it should give you 300 naira. But in this case, it wasn't doing addition, it was doing concatenation. Concatenation is when you join them together, 100 and 200. So instead of having 300, you're having 100,200. So that looks like a minor mistake, but imagine if that app had gone into production without us catching that bug. It would have been really bad. You'd have just noticed a lot of people cashing out. So in that particular example, what happened there was it was a data type issue. Those data types were being stored as strings instead of numbers, and when you try to add strings, it's going to do concatenation. So you're going to have 100 and 200 all joined together. So that's 100,200 instead of adding. But if they were stored as numbers, it could have added them properly to get 300. So that's one. So that's why you actually need to understand data types so you can avoid mistakes like that. So let's look at some data types in Postgres. We're just going to look at a few. One of them is characters. So you can see characters are string types. They're string types, they are general purpose types suitable for any combination of text, numbers, and symbols. So what this means is we can use characters to store things like titles of movies or title of books, the name of a person, the description, anything that has text or combination of text and numbers. You can use characters to store them. So other character types, we have the char, we have varchar, we have text. I'm going to explain what the char means. This is a fixed length column where the character length is specified by n. Let's break it down. So let's say you have a particular data you want to store, and you know that particular data is going to have a fixed length. A perfect example is, let's say I want to store phone numbers, and in Nigeria phone numbers are about 11 characters. They're 11 characters and that's fixed. I know that this data I want to store is going to be fixed all through 11 characters. Then I can use this char data type. This n here actually represents the number of characters you want it's going to store. So that would be like char 11 in my case, where I want to store the phone numbers. So I know that no matter what, it's always going to be 11 characters there in that particular column or field. So storing phone numbers here will be perfect, because no matter what, I know my phone numbers will always have 11 digits. Now what happens if what I'm storing is not up to 11 digits? Then no problem. What Postgres is going to do is Postgres is going to pad it. So if I'm putting something of 5 digits where it should be 11, Postgres is just going to pad it, like probably add zeros maybe in the beginning, so at the end of the day everything will be like 11 characters. So in situations like this where I know that I'm not going to always store 11 digits, it will be better to use something else, because if I don't store 11 digits, then I'm just taking up unnecessary space in the database. So that's where varchar comes in. Varchar, think of varchar as variable character. So it's variable length, it's not fixed, and all you need to do is specify the maximum length. So that the n here is just going to represent the maximum length. Okay, let's say I want to store phone numbers, still phone numbers, but maybe phone numbers in different countries. Now I'm not focusing on Nigeria. I know that the phone numbers for other countries could have different lengths. Some could be 8, some could be 12, 13. In this particular case, varchar will be perfect. To be perfect in the sense that if I can just specify the maximum length, like that n, the n here represents the maximum length, like no matter what, it shouldn't exceed this length. It can be less, no problem, but it shouldn't exceed that length. So if someone is imputing a phone number of 8 characters, then that's fine. It's not going to take up unnecessary space in the database. There'll be no padding. Postgres will understand that, oh, okay, for this particular one it is 8 digits, or this other one has 9, this other one has 10, and it's okay as long as it doesn't exceed 15. So that's how it works. So that's why most of the time you see people using varchar. I see people use varchar a lot in their database. So it's better, except you're really sure that the characters you need should not be below or above that length, then you can use char. Right, so let's see text. Text, variable length, column of unlimited length. This one said unlimited length. You do not know how long the value you're going to be imputing there will be, so it's best to use text. Now this is perfect for description. Maybe you have a movie database. And you're storing the title of the movie. Maybe title of the movie, you can use varchar, because there'll be different movie titles of different lengths. Then you have the description of the movie. You're not sure the number of characters that'll be there, because the movie description can be very long. So it's better to use text as the data type there, where you have unlimited length. So all of this just has to do with characters. Let's move on to other data types. Yeah, we have integers, whole numbers, both positive and negative. So when you want to store whole numbers, that there are no decimal, no floats, nothing like that, just whole numbers, then you can use integers to store them. So we use integers to store things like total number of orders. Okay, how many orders is this person placing? Is it placing 3 orders, 2 orders? You know, for this kind of example, you can't say someone placed 2.5 orders. That doesn't make sense. So for cases where you know it's not decimal, it has to be whole numbers. Integers that are perfect for it. So you could use it to store total number of orders. You can use it to store the stock quantity, number of stocks left, and things like that. So breaking it down, we have small int. Now you can see the size, the storage space it's going to consume. It takes about 2 bytes. It's consuming 2 bytes of storage, and it ranges from minus 32,768 to plus 32,767. So if the number you want to store is going to be within this range, then you can use small int. So you say integers takes about 4 bytes of storage, and you can see the range. So if you have any number that you want to store in your database in that particular column, and it will be ranging from this to this, then integers are perfect for it. Now if the numbers you want to store, it's going to exceed this, and maybe something really huge like billions, trillions, then you can use big int. You can see big int consumes 8 bytes of storage. If you know the number you're going to store in that column won't reach this length, then you can keep it at integer, where it's going to consume less storage, like your database won't be taking up much storage space, instead of using big int and you're not even going to store numbers that are up to this range. Hopefully if you want to store my bank account balance, you can use big int. I hope you can use big int. I just hope one day my account balance will reach the point where I can use big int. Right, jokes aside, moving on. Now we have decimal numbers. Decimal numbers. You can use this data type to store things like temperature, distance, rainfall. Now in this case, you show that the value will be a decimal number, because the temperature could be about 23.5 Celsius, degrees Celsius. It could be, or the distance, could have distance where the distance could be maybe someone traveled 5.6 miles, 2.7 kilometers, or the rainfall. You know that these particular values are going to use decimal numbers. Now let's break it down to the different types we have under decimal numbers. We have numeric or decimal. So you can either use numeric or decimal. And we have the P and the S, which stands for precision and scale. So precision is the maximum number of digits, like the maximum number of digits you're going to store. You can just set that in advance. It could be less, but that would just be like the maximum. And then scale is the maximum number of digits after the decimal. So I have this example here where we have numeric 5 and 2. So numeric 5 means totally the number of digits there should not be more than 5. In this case we have 1, 2, 3. 3 digits, it's not up to 5, so this is okay. 1.00, also 3 digits. You can store something like this here. And we have 1, 2, 3, 4, 5, so 5 digits. Numeric and numeric 5, numeric with a precision of 5 can store numbers like this. Now if you know that the number you're going to store, the decimal number you're going to store, will be more, then you can specify the precision. Maybe you can specify it to be 10, even though it's going to be 10 digits in total. Now these two just represents the maximum number of digits after the decimal point. You can see that all of them have 2. You don't have more than 2 digits after the decimal point. If you are trying to store something with more than 2 digits, I think Postgres is just going to approximate it to be 2 decimal places only. Again, 5 represents the maximum number of digits in total. That's both left and right, after both before the decimal point and after the decimal point, left and right in total. Then 2 represents just the maximum number of digits after the decimal point. We have other data types you can use to represent decimal numbers. We have real. Real, it's like keeping it real. So we have real. So this allows precision of about 6 decimal digits. So 6 decimal digits. If you want to have 6 decimal digits in total, you can use real. Then you have double precision. Double precision allows you to store up to 15 decimal points. So if it's going to be really large, you can just use double precision. But most of the time I see people use either numeric or decimal. People use numeric or decimal most of the time, but you can use, just in case you see these data types, you know why they are using it and what it's doing. That's why I'm touching all of this. We also have dates and times, and this is important when you're doing analysis like time series analysis and things like that. In Postgres we have timestamp, we have date, we have time, and we have interval. Timestamp basically consists of the date component and the time component. So now you can see what day it is, and you can also see the particular time, hours, minutes, and seconds. And we have dates. The date contains just the date. So if you just want to store only the date without the time component, then you can use the date. If you want to store only the time of the day, you do not want to store the date, then you can use time. And if you want to store interval is the time interval. Maybe something takes 3 days, 2 days, 5 hours, 3 months, 5 years. You want to store data like that, then you can use the interval. See, you can also see the storage. So the list here is date, but again, depends on the kind of date you want to store. If you need both the date and time, you can use the timestamp. Another popular data type is the Boolean data type. So yeah, this meme, to normal people, you can just see it as true or false, 1 and 0. But to programmers, it's something much darker, because Booleans can be tricky sometimes, especially when you're doing logic, gates, logic. Yeah. So Boolean data types, if you want to store things like subscription status, where the value can either be 1 or 0, true or false, yes or no, and you use Boolean for things like that. So a user may be active, a subscription may be active or inactive. So that's an example for Boolean. A user may be active or not active. A subscription may be active. Or another one is if a product is available. Maybe you have a database like Jumia, and you can see if that product is available, yes, no, 1, 0. And security access is maybe someone has access to a particular platform. Let's say a particular sheet. If this person has access, could be 1 or 0. So things like that. If you want to store anything that requires yes or no, true or false, then Boolean is the data types used for things like that. So that's it for data types. There are other data types in Postgres, but these are the common ones that you need to know. So thank you for watching. If you're new to the channel, please subscribe to this channel, and please remember to like this video, especially if you learned something from this video. So see you when I see you. Don't be a stranger.